In 10.3b, we are going to transform from polar to rectangular equations. Now, it talks about doing this on your calculator. I'm not going to do that. I wouldn't ask that question. But so what? Well, I guess I should have said we're going to be going from rectangular into polar, and I think in the last video in this section we'll be going the other way around, which is a little harder. So what we want to do is go from the rectangular system, the Cartesian system, into polar form. And what we're going to do this is we're going to use these two equations. We know that x squared plus y squared equals r squared, so this would be from rectangular over to polar. And we also know that x is r cosine of theta and y is r sine of theta. So all we're going to do here is use these tools in whichever way would be the easiest. Now if you look here, I have x squared plus y squared equals 9. I want to turn this into r squared so that we can be talking about this. Yeah, they didn't do this in the easiest way possible. Okay, so we have the two tools. Now you'd get to the same place. What they did is they made the switch by squaring these. So I'll show you what they did here. They replaced x with r cosine of theta and y with r sine of theta, which is legitimate. And then they did a bunch of distributing. And then this, we know from the Pythagorean identity, is just 1. Now, we'd have r squared equals 9, where r is the square root of 3, so plus or minus, or square root of 9, which is plus or minus 3. Now, that's fine, but you could have jumped right ahead to use this definition instead, and you could have gotten immediately to r squared is 9, and r is then square root of 9, so that's plus or minus 3. So this is Cartesian, and we wanted to get in terms of r and theta. Well, getting to r was very easy here because we have one of those definitions. Is there anything else here? Yeah, so if there's no theta here, what we're saying is r is always 3, or r is always negative 3, and it would make those circles. Which, again, this in polar form, this makes a circle. Okay, so let's try to do this again. So I'm going to use my tools again. I see that this makes r squared, and over here, to get rid of y, I'm going to use y equals r sine of theta. So I think they're going to do the same thing. Yeah, so they made r squared equals 6y. Now, let's sub out y into something that talks about polar. Well, y is r sine of theta. Now, we're not done here. We want to solve this for y. So we're going to send everything over to the left side. We're going to factor out an r. So this has a simple factor. I'm going to factor out an r, and then the zero product property says let's set either one of these equal to 0. So we've got r is 0, and then r could also be 6 sine of theta. So here we have two equations that we've generated that are all about r and theta, and no more x's and y's involved. Now here they point out that r is 0 is nothing. Like if you were in polar coordinates, that's just the origin. There's only a single point. So that isn't a real valid equation here. But r equals 6 sine of theta would be. So this is our real equation when we've converted to polar. Here they have graphed them for us in each of those forms. Okay, let's try again. We're going to go from Cartesian into polar. So I don't see any tricks here with x squared plus y squared, so we're just going to sub in that y is r sine of theta and x is r cosine of theta. So we're just subbing into the other version, so we come up with this. Now, they're going to solve for r, so what we're going to do is send everything over here. Let's get all the r's in one room. So we did that here. All the r's are in one room. Here's a trick we see a lot in college algebra. They're pulling out a GCF of r. Now, if I want r alone, all I got to do is divide 2 by sine of theta minus 3 sine of theta, and I've got it. Here's an equation for r. In terms of only r and theta, we've gotten rid of all the x's and y's. Okay, this is a very short section. I think we'll go the other way, I believe, in the next section will be a little harder. But we want to convert this into polar form, and you might be thinking, okay, well, y is r sine of theta, and x is r cosine of theta, and that would get you there. But it's going to have a lot more work. Let's do this. Let's just send the x squared over to the other side, and we can use the fact that x squared plus y squared is r squared. Much easier here. Just send that over. Then we know this is r squared. So r is then the square root of 3. Okay, so we're just going to use those two tools to get rid of all the x's and y's. We're going to use x squared plus y squared equals r squared. And we're going to use the fact that we can convert from x because x equals r cosine of theta. And we can convert out of y because it equals r sine of theta.